Yes, madam, you can start now.
All units will be here.
Right.
Good afternoon. Am I heard? Hello, am I heard?
Good afternoon, madam. Good afternoon. Welcome. You can start.
Yeah. So I will give a glimpse of robotics research, what I have done. Just a part of that I'll be able to say, and I would like to share it with you people, all of you in both the campuses of this institute where I have newly joined. The robotics is actually a multidisciplinary field of research where different department people must work together to be able to have some common outcome which will give everybody a great satisfaction that all of them together have worked. This kind of research cannot be with single department. Hence, multidisciplinary research in robotics and allied areas is the today's talk which I'm going to give. The research work is executed on the funded projects. I have only worked on funded projects from the day one, and they are from Defense, DRDO, DST, Department of Science and Technology, VTU, Vishishraya Technical University, IEDC, which is a part of DST, IEEE USA, Vision Group of Science and Technology, Karnataka. These are my funding agencies over a period of 11 years. Students from different branches, mechanical, electrical, electronics, computer science, information science, and aero have worked together. So this is my multidisciplinary team, the research in robotics and allied areas. So I have mechanical, who do the design, analysis, fabrication of the systems, whatever system we develop, the control system, the control, navigation, embedded system, all these things are done by them. Then comes computer science, image and video processing, computer vision, and at the end you need electronics, hardware implementation. There are fields like machine learning, artificial intelligence, deep neural network, convolutional neural network. They give a value to your work and make you to publish the best papers. Data and video analytics is another area where you work on advanced video processing, data and video analytics, agriculture, healthcare, disaster management, activity tracking. These are the today's area. I will only first show you just a small glimpse of the robots which were built in-house. It started from the year 2009. Center for Robotics Research was set up by me in the year 2009. 2008 I joined and the first work was satellite. I will show a glimpse of this if I have time. And these are the indoor mobile robotic platform which was made by teachers and students from mechanical engineering department. So next comes, once this kind of simple platforms have been made, experiments have been conducted with them, and learned the fundamental things of robots, navigation, control, all those, we come to mobile robots. These are mobile robots and some of the technology. In the second picture you see, that is actually a number of series of sensors, which has been, these are the series of sensors we have made, and those sensors are used to see the panorama around the environment, all our sensors. These are the sensors we have mounted like this. This was all done in-house, only by teachers and students. These are the cameras which uses the panoramic camera. Next. These are other kind of mobile robots. Over a period of time, as I get different projects, we go different type of work we do. And then we develop the hexapod. There you are seeing two hexapod. Next. And then comes the mobile robots, which are four-legged mobile robots. The red and yellow can go on a flat terrain. Then came the green one, which came through an uneven terrain. It all depends upon the requirement of the project. The initial project came from defense, where the robots were supposed to be used for delivering food items in the frontier areas of the country. And on that, this was done. Then we came out with humanoid robots. The two different types of robot we have made. The one which you see the first, that is called Arya, name is Arya. advanced robotics from innovative application, and Dia, that is the name of the lady we have given. They all do different kind of technology. We have proved the technology through this role. Robot is nothing but a platform. Instead of robot, you can bring a vehicle, you can bring an aerial vehicle, you can bring a ground vehicle, you can bring an underwater vehicle, you can test your algorithm. Basic is new algorithms we have to do in different areas, make our students empowered by that. Only then your students will get the best place in everywhere. So I will only take a small part of the work today in this lecture. I am talking about human tracking by mobile phone. I will go a little first for the reason that details of which you are supposed to do it yourself. I will only touch upon the areas and show you what is the kind of things we have done. Next. So I will not go through that. This only shows the computer vision, what is very much important for autonomous tracking. It is the autonomous tracking by a robot. He tracks human, he tracks vehicle, he tracks multiple activity with that. Next one, please. So this is the tracking, a simple scene of tracking. You see on the left hand side, you have a car, and you have been able to identify where the car is on the scene. It doesn't go automatically, please. You can do it by just clicking, but that has got no value. You are supposed to be automatically identify the target. Here I call the car as a target. I can change the car to different kind of vehicle. I can change the car to a human being. Human being is going, I am following the human being. And in the right hand side, I have got one template of this particular car. There is a difference between the picture, what I take template, over a period of time that when car goes, it may not have the same look, but I should do some algorithm with the help of which I identify, yes, this is the same car what I am having in the template. So here is your template, and here you see that particular car at a certain time you have taken this picture. And now today it is going on the road, it is looking like this. Is this the same thing, please? See here and see here, there is a difference, but still I should understand they are the same vehicle. That's the technology which is called tracking, the basic technology of registration, image registration. It is not taught in the class because this is not in the general class syllabus, but it is a topic which is available in multiple places. So methods of registration. How do you register two different objects looking different? They are actually the same. How do you sort them? Here is the motor. Here is a big area. You have got other things. Remember that. See here. There are some sand. There are some road. But you should still understand this is the thing. So searching strategy. And how do you accurately do that? These are the three important parameters which must be taken care and optimized to be able to get a good result. I will not go for details for anything. These are all available. In the net it is there. Multiple methods are there. It is little older. I started from there. Next one, please. And then I have got a number of different type of algorithms are there with the help of, these are the things which are the matching strategy, tracking. How do you do the tracking? And how do you really find out the parameter? These are the different methods, sequential similarity difference algorithm called SSGA, Spearman algorithm, cross correlation algorithm, normalized cross correlation algorithm, normalized area correlation algorithm. These are the all different algorithms came over a period of time by research of different people. Students are supposed to start from this point only because the funda of the subject must be clear. Today, if I tell you a big problem, you will not be able to do till you know the fundamental. Next one, please. And then we apply, we show the application. Here is somebody standing here. He is actually my student who is now a big person in Germany. He has done his PhD in Germany. He has worked with me in undergraduate and then after that got into Germany in a postgraduate program with PhD, and today he is a big person. So this was when he was in Bangalore in our college. Now this boy, he is a target, let us say. What is my first one? I will find out around him there is a box. Has it come automatically? No. Have I drawn it? No. I have done it through programming. That means there are ways by which in a scene, who is the human being? And can I make a box around the human being? Can be done by algorithms. They are called what is that? Segmentation. One second. That is an algorithm which will separate an object from the background. The initial algorithms are called thresholding algorithms. But thresholding methods are available in the book. that thresholding method will not work. You are supposed to do a number of thresholding methods. There are research papers available, a large number of research papers, and we have mainly worked on Kittler method, Fiddler method, Kittler, Riddler, Sally's, and Lee. These are the 4 methods which are available only on research paper, are good for application in this kind of domain. We have used this method, Kittler, Riddler, Sally's, and Lee's, and then found out in which situation which one works best. Not that all these methods will be working in any environment. Depending on the environment, you will have a different algorithm. That has to be found out. This area of research is called quality metrics, QM. So QM is an area which is the most important in any image processing, be it application in defense, be it in normal application, or it is also in medical application. So first type, this is the object I have identified. Now I have to find out the object which is moving, and I am supposed to follow this. How I will do that? So I have to search. The object is moving, but here actually it is a video. I will show it later. At present I show an image. Now I have to search when it is moving, where it has gone. So I will search it throughout the entire object. First way of doing it, I will search this picture everywhere. Then I found out where it matches next. By what? I showed you some different methods. With that measurement parameter, you are supposed to search. I showed you just now a number of methods, number of different methods. Just go to the number of different methods. These are the things. These are the parameters with the help of which you will make the search. Okay. Here you have the parameter for both the search and the object. So once you search it, you find out approximately where is the object. You have found out that. But when you search, you are taking a window and you are putting this window all over the image to find out where it matches best. When you have got the matching, you have taken a step of 5. See here. So it means I have taken windows here and I have moved the window to 5 pixels, which I have made little inaccuracy. Now I have got where it is approximately. I take a bigger window and search after every pixel, and then I get exactly the correct position. If you search like that, that means you have an object here. You can now replace the human being by anything in the world. You can take some object. Okay. Now this object was somewhere. It is moving, and I am every time finding his new position. And that is the thing. What is this one is doing? What was the time needed? I am searching at the beginning, entire screen. I am finding approximate position. I am taking a find search. This is called coarse search, and this is called find search. In find search, I know the exact location. Is it possible to do it in a real time only by software? No. So working on hardware board is an essential part of image processing. If you want to really do something and just theoretically not put it in the papers or not publishing it as a real-time application, you need hardware board very efficiently. Now, since I have taken the entire area to search, my timing you see here, 0.1620 millisecond. This is the time I have taken to search the entire object, 0.1620. Okay, now let us go to the next one. Let us see here. I have not taken the entire screen. It is taking too much of time. So I have taken an area. I have already found out his approximate location at the beginning. So I found out an area near that. Make a coarse search and then make a fine search. Can you see the time now? 0.04 milliseconds. Have you understood that? This is the thing you are supposed to write in code. In your C, C++, Python, today's children use Python. You use it Python. Please learn coding. If you do not know coding, no good work can be done. So this is the fundamental technology of tracking. Next one, please. And then I do it for the car. Just I want to do the same thing, just to show you. It is the exactly same. I take the entire area here for searching, and then I do the fine searching. I get 0.1600 milliseconds. Next one. Now I do a fine search. I don't do everything. I do the area near that and see my time 0.0290 milliseconds. Have you understood this? This is the fundamental basics of tracking. All these are done by students who has worked and who has learned things. Next one. So this is mainly called registration. So registration methods. Now methods are, these are the different methods. Sequential similarity detection algorithm called SSDA, Spearman cross correlation, the normalized area correlation matrix NACM, which is supposed to be one of the best methods, Pearson cross correlation, normalized cross correlation, cross-sectional histogram correlation, mutual information. These are the different methods. Whenever I take up a work, I make my students work hard and do all the different methods. Then searching strategy, find search, what's to find search, around the object start using find search. These are the three different strategies of searching. And then the accuracy of tracking. There is some parameter, I told you just now, quality metric parameter. Without that, I don't do any work. Or no work on image processing has a value if you do not have the quality metric parameter. What are they? Pixel cross correlation, then house drop distance, and then discrete approximate matching. These are the three parameters which will determine the suitability of your algorithm for the given application. Again, you remember, all these are different algorithms. All these algorithms have place somewhere, but depending on the application. In different applications, different methods should work better. So the students are supposed to do all these algorithms. The algorithm's detailed steps will be available, everything will be available in the internet. And then you implement this algorithm, use these parameters, learn how in different domain you will have different kind of parameter best. In some case, pixel coordination works much better. In some case, house drop will work much better. It will depend upon what is your vehicle, what is your object, what is your background, and where you are doing this one. Okay, so this is the first one, area-based matching, it is called. Next one. So this is the result of that. One second, it should come. This is video. Video is not working. Yeah, it's working. Just click on that. Every screen. So these are all video. It should work actually. Okay. Just click there. No, this is the machine has to be very high-end machine. Only then. Okay, the machine has to be a high-end machine to be able to work on that. Maybe the machine is not. So all the videos will, all of them are video. So anyway, this is the way it will work. That as you do, the human being is followed by a serial, a bounding box I have put here by which it will. Actually, all of them should work. In my machine, it works. Okay, it's all right. All the video may not work. This is sad. It's not people know. Automatically. Okay, next one. Now, this I won't go detail, but what I want to say now, the next situation. What is the next situation? You are following a target. For some time, your target is vanished. You are not able to see that because some obstacle has come in between. You use something called Kalman filter. And these are the different steps of, I will not go through the detail, initialization, prediction, correction, updation, which means you have initialized the scene. And when you are not able to see, you are doing prediction. Where it can go during for some time, I don't see the target. I am not able to follow it. So I do prediction. And then I put a correction on that to see whether my predicted position is correct. And then I do updation. I will do correction, then only I do updation. Next one, please. And there is the mathematics of Kalman filter. This Kalman filter, if anybody wants to do this work, they are welcome. They have to understand this predicted phase. These are the mathematical equation who is holding that Kalman, governing this Kalman filter. And when the Kalman filter is there, you'll be able to pass through obstacle. It is very sad if it doesn't work. The video doesn't work. Next one, please. So this is not video. So I'm showing here. You see, here is the object, which is you have put a box around it. Now it is going through. It will come here, it will go through obstacle. See, here is actually the chairs are there. But still you are able to see that. Actually the person is passing through a chairs in front where his whole body is not seen. But your prediction algorithm will show you by Kalman filter, which will predict the position of the object still when it is not seen. Next one, please. So like that way, you have seen here, for some time, you see here, it is vanished totally. The object is not there. Now the window is only going. Object is not going. Here the window catches. Once from here, object is not seen at all. The human being is not seen because he is covered with that chair. And now I'm putting still, I'm predicting this window. It is red color. And then it comes to green color and come back to the object. Next one, please. Next one. This is another example. Next. Now I come to the Kalman filter video. See here. See here. See, here is this one. See here. This is. For some time I can't see the human being totally. Human being. See, look at the human body which I am tracking. I am not able to see the human body fully here. I am not able to see it. But still, I am doing with the red color. I am doing the prediction. So here is the prediction again. See here. See here. For some time I cannot see, but still I am predicting this prediction. Next one. So then comes the next method. Series of methods called particle filter. This has become very famous across the everywhere research circle because of the, see, what is the final fundamental of this? Here also I find out where is the human. This particular thing you must find out by using adaptive thresholding algorithms. As I told you, there is a number of algorithms. There is a research paper is available in the net where there are 40 different methods done by Indians and American scientists. Indian scientists are some of the people in IITs who have done work, and they have put their methods also. So people like A.K. Jain, people like, there is a number of people are there who are from India, and they have also done a great work, and their name is also there in that paper. This particular thing, so automatic identification of a human body in a scene, a target, it could be a vehicle, it could be a human, it could be anything. But how do you determine it automatically and put a box around it? One way is you click it and make a manual target. That has got no meaning. None of the automation process human beings should be present there. No human interaction, everything should be automatic. Then what you do, you put from random number generator a number of dots around that, you throw it and find out as it is moving, these dots, some of the dots will be near him and some of the dots will go away because they are not able to calculate. And then you say those things which are around it, they are the one who is following the human. And I will show you some pictures. Here, automatic detection of target is the most important. Automatic initiation of tracking. You have determined the target. So what? You have to start tracking. That means you are supposed to generate random number generator this data, and that will be around the object. Object is the target here. Distance measure. How do you know which particular, as it moves, as the human moves, some of the dots will be able to follow him. Everything cannot follow. And that will be done. Which of the things are following? The measure is, these are the measures. A number of measures, a number of alternative methods, Bhattacharya distance, chi-square distance, correlation distance, intersection distance, all these different formulas are there. Methods are done by different scientists, and you can take them. Again, you can find out who is the best by comparing the different output. Resampling. Why resampling required? After some time, as the human is going, dots are following it. Dots are generated by random number generator. Over a period of time, their strength goes away. And because their strength goes away, you are supposed to do resampling. And there are 3 different methods of resampling. Students who would like to do this one has to do hard work. They have to do all the methods. They have to do all the resampling methods. Learn the funda of the subject in one day to be able to manage, to be able to teach people. Only you get that capacity when you have done the work yourself, and don't take other people's material, or don't use MATLAB to do all this for you. Then it has got no meaning because you will not learn anything. Next one. So here is this one. These are all video, but I'm very, very sorry to say I don't know. I didn't know that this doesn't work. Anyway, so this is the object, and this is the automatic thresholding has been used to separate the object from the background. And then you can do tracking. I told you Kittler, Riddler, Sally's, and Rees. This is Riddler's method. This particular work has come from Riddler's method. Next one, please. Then comes this. These are also a number of, these are the picture. This is a picture. This is not a video. I'll show you the video. I hope it works. Here you are seeing how the particle filters are being reducing, and then you regenerate them. Reducing, you regenerate them. When reduce means what? Their strength goes away. Then they are not able to follow. So you have to regenerate the particle, resampling. Again, resampling you do, and go on doing that for a continuous time automatically. No human being is required. Next one, please. And then you see, oh, I'm so happy that it is working. Here, you have done manual detection of target, but then it follows particle filter. Here, automatic detection of target. See, I've done a window, and then it goes completely. You follow the target. This fellow is one of the best students from my college, and he is actually in Germany today. He's doing a great work in a company after his master's and PhD. Okay, next. Then we come here, and here also all these are particle filter application, and these are all video, and I hope they work. Okay, now you see here, please check this particular picture. He is coming here. There are green dots I have kept purposely. These dots are nothing but that random number generator output. See here, this fellow goes away. He doesn't confuse. That is the main thing. That picture now should not go to that white dress boy. That is the reason we put red and white to show how strong of the algorithm. If the algorithm is strong, this window will go to that boy. It will not go. That is the thing we'll see. This is a very good work, and let me see whether it works. No, it is not working because it's sad. Anyway, doesn't matter. Something I have been able to show that I'm happy. This boy with red contains the particle filter. I am working with him. This fellow comes in between. Neglect him. See, you are neglecting. This is the importance. Very, very important this is. In many algorithms, if you have not done it properly, it will go from red to the blue bar and will start tracking the blue bar. It will not happen because then it will be there. That is an error. Next one, please. So there are two most important filters. They are the variation of particle filter, auxiliary particle filter, memory-based particle filter. I just told this to you because two of my students who have done this work are today in the best universities in US doing PhD. Next one, please. Of course, everybody has worked on embedded hardware. Now, these are all my MTech students. This particular work was done by MTech students. Unfortunately, the video is not working. Anyway, this is auxiliary particle filter, memory-based particle filter. I am very much interested to show you this. What is the reason, do you know? I have put blue color, I have put red color. They will cross each other, but still they will keep their identity. They will cross each other, they will keep their identity. It is not working here. Okay, now these are nothing will work in real time without a hardware board. So I put here Beagle board, Panda board, and Udo board. Udo is a 4-processor board, and Panda board, Beagle board are all on processor board. And those are the boards. And there is one more board, Jetson TK board, that I have not brought it here, but we have done it later actually. Okay, next. And now you see how that board has now this is with embedded hardware board. Have you seen how he's jumping? Have you seen how he's jumping? Have you seen they are running now? Because what? You can do it at high speed. You can do everything. See here, he crosses. This boy, the boy who crosses now is in Japan now. He is one of the brilliant students who have worked on this system, and he is being placed in Japan by HCL Tech. I have placed him in HCL Tech Bangalore at the beginning, and he has become permanently settled in Japan because the Japan customer doesn't want anybody else except him. So these are the Beagle board we have used that. Okay, next. So these are the different type of work. Then the DST who funded that project suddenly made a thing, we want outdoor. So we went to the railway line. Does it work on outdoor or outdoor it stops? Many people shows the work only in indoor. They are not happy. They said, we would like to see it in outdoor. To see in the outdoor environment, light has not created a problem and it doesn't work. Sometimes it happens. Outdoor light is different. So naturally it may not work. But you see here, we have taken, this is the railway track on which we are doing. Here is the outside in the college premises, outside. Okay, next. So now I will show you how we are integrating the system. Okay, now mechanical, electronics, electrical, all work on their own way. I have shown you so far mechanical, and I have also shown you, I didn't show much on mechanical, but I showed you something on electrical electronics they have done. Let us see what comes on way forward. So here I come to the control system, and control system is an open loop system and a closed loop system. In the closed loop system, we have linear control system, we have non-linear control system. Each of them have some characteristic. I don't want to spend your time when reading this slide. It is not required. Everything is available. Now we come to the different control system. Next one, please. So this is a PID controller, and this is the characteristic. The merits of the controller is knowledge of the system is not required, and it is easy to implement. P, I, and D, proportional, integral, derivative. And it is demerit is tuning of the gain parameter is difficult. Show response time, slow response time. This is people who are electrical people will be going through this and will learn it automatically. It is not required here to say details of that. We have worked on PID controller at the beginning because it's a linear controller, but it has got certain advantage and disadvantage. Next one. Now we come to the linear quadratic regulator, which is the next control system, which is actually a non-linear control system. LQR has a settling time and rise time when compared to PID. And LQR takes the external disturbances into consideration, whereas PID does not. That is one most important parameter. What is the demerits? LQR is complex to implement when compared to PID. PID is a much easier to do, whereas LQR is a little difficult. But the thing is that when students learn that, it gives them a boost in their work, in their game. Next one. Now we do a number of variations of LQR we did, which is called LQG, linear quadratic Gaussian. I will not go into the details of that. Students who are interested will be automatically getting everything and they will learn. Only thing the interested student has to come, put their effort to be able to apply it to different systems to show their performances and prove the concept to do the right work. Next one. LQI, linear quadratic integral. This is again another learning. All these are variations of LQI. Okay, next. Then comes the model control. This is another control system we want. I will show you what are the applications. Now what happened? The computer science people comes here, identify the object first. They identify the object and they try to find out from that object. It tries to find out first is the human being. This is the human on the scene. You do automatic detection of target by using, I told you already, adaptive thresholding, and then you come to target tracking. Up to this, you can use by CS and EC student. I have got a number of electronic students who works on same, they're doing the coding, everything they know. Same thing, CS also. Even CS people have learned embedded hardware code. Don't make a distinction between the department when you work on multidisciplinary project, because a CS students get benefited by EC by learning from them the embedded processor. EC students get enormous support from CS students by learning the coding. So they are all together, and then comes my control system. What is this? This is actually this is interaction matrix, which is actually putting this human being body. What I'm seeing the centroid of the tops. That is my target region, which I'm going to track. And now that has got my XY coordinate. And with that coordinate, I'm converting it to the image coordinate UV. And that is the interaction matrix does that and bringing this tracking to the camera velocity and camera point fix. And then it is converted by the control people to the wheel speed. Finally, it is the wheel speed. As your different steps are coming, what is the amount of the rotation of the wheel as it is moves in them? So that is the thing what is to be finally determined. So this particular integration between the CS, EC and electrical makes the entire thing as human tracking. And basic robot platform, who made it? Mechanical players. Without mechanical, you cannot do anything. They will give you the platform. And that is the way all the departments works together to finally make a robot which will follow you. Okay, next one. So then you come, you have got all the department and it is going on different path, it is doing various activities. This is robot 1, this is robot 2, a multiple robots you have got. Next one. So now you see this. These are earlier one, but I'm just showing it to you. Next. See here. This is a EC student who did his MTech. This is his MTech project, what he's showing now. This robot will go for a long distance. These people are all my best students. All of them are in different parts in the world today. They are earlier students. This is my earlier work. So all the students publish a number of papers and thereby get a great name everywhere to whatever university they apply. Next one. This is another student, mechanical student. This particular robot goes to in uneven terrain. Supposed to be. Can you just see that, please? Oh, it's not working. Sorry. I just go forward. This should work actually. It is not working. Okay. This particular robot will go there or will go to a little up and then come down. Anyway, this is a teacher, of course. This is the mechanical teacher who designed this particular robot, which needs to go to an uneven terrain. Okay. I will go to the next presentation, please. Yeah, just next. Come on with that. Close it. Close the next. Come on with that. Robot. No, first one. Yeah. Robotics, that's it. Yeah, second. I want to give you a glimpse of the last project of Department of Science and Technology. Yeah, just show you that. Yeah. Share you have not done, no? No, share has to be that.
No,
No, one second, because it's share, it's coming. It has been not shared.
no, it's not.
This is the presentation, no?
This is the second presentation. Share.
Okay.
Sharing class.
Share.
That one.
This one.
This whole, you can come out of that and share. Share. Hello, everybody is listening. Just go to the first. Everybody is able to hear it? Dr. Jagannath Badi? Jagannath Badi is not responding. I just called the sorry, not that. Okay. So, let's just ask the question. No, ask the question.
So it's a total.
No,
Yeah, it's audible.
just ask the people. No, you ask the people now. Just ask the people. Anyway.
I think madam is audible. Hello.
Yes, sir.
So this is just a small glimpse of Department of Science and Technology project, this is my last project of Department of Science and Technology, the most current project. So I wanted to show you just for you to have an idea what kind of work we should do. Next one, please. So this is my team. In this project, these are the people who have worked, faculties, research associates, and students from different departments. Next one. So you have to we have given these 4 projects, we have done our work. The goal of the project is to design and develop mobile robots, because that was the time when we did all-terrain mobile robot, the first top robot, which is actually this robot actually can go through an uneven terrain, this particular robot. To design and develop mobile robot, important features are what? Let us see the important features. At first, nonlinear control system. The control systems I showed you. Computer vision algorithms, and then it will tracking a human target, and then along with that, it will be in clean environment, and it will also be in clutter. That was the objective of the project and the key challenges of the project. First is bringing a robot, designed robot, which always this goes to a flat terrain, bringing it to a terrain which is very much not smooth and wavy terrain, bad terrain. And this 2 hexapod was one of the reasons that was attraction of a number of people who we had already presented in some other places. So one hexapod was already there. This is the hexapod we have made, but unfortunately, hexapod can do very interesting work, but I have not been able to bring them here because that slide is not there. Anyway, so I will just show you certain glimpse of a project output. Next one. Now, these particular factors which have been responsible to introduce inaccuracies in tracking, cluttered background. So cluttered background is two types, object clutter and environmental clutter. Object clutter, we use there's a number of objects are present there. Objective of this project was that it will be a technology demonstrator to DRDO to be able to develop something which will be able to give in the frontier areas of the country where food is given by helicopter, and some soldier picks up the food and give it to everyone who is living underground. Now, this particular work, a soldier was carrying the luggage himself, was replaced by mule some time back, but still that they wanted the robotic vehicle. And that was the way this project came to be. With a large number of people, I have done that. Which are the area? Look at the area where the robot has to go. So naturally, I don't have outside region. So what we have done in the corridor, we filled up with various things and used that as cluttered environment. We called some people, small people from here and there, to create this kind of environment in the corridors and the rooms, big halls, so that we can do in this kind of dark environment. The food article comes by helicopter, and the helicopter drops the food item on the ground on a particular area, which is under one commander. Every areas of the country, surrounding areas are under different commander. In one commander's area, he is responsible. He has one or two such people to carry the luggage, carry the food item. Now, this particular area has come at night. Let us say by 8 o'clock or 9 o'clock. Nobody can see anything. There is no light. So how the robot will see? So that is the challenge of the project. There is an area which is actually an area which is our country's border area, but very much cold. So all the time there will be this kind of cloudy environment. And then there are noisy environment for the desert area, which are our country's border are passed through different kind of natural calamity. And these are the things. So we wanted to show you the technology. How do you do tracking with that? So these are I showed you this, the two filters, particle filter, which are very famous. One is auxiliary particle filter, another is memory-based particle filter. And these are some output, they are video. I'm not sure whether the video will work. It is very sad, the video is not working. Anyway, so these are where the people will, just a demonstrator. And here you see, the people are, here there are particles and there is a complete human being. You have taken a bounding box around them, and he can move anywhere. This box can move. These are only the technology demonstrator of the particle filter. Next one. And then we have done here mean shift and cam shift. Where we have done, they are the different tracking algorithms. Previously, I showed you first with area-based registration, but I showed you at the beginning, first one. Then I showed a number of methods of registration with Kalman filter for obstacle avoidance when you have obstacle in front of you. Then we came to the next method, which is your particle filter. And now we are coming to mean shift and cam shift algorithm. They are nothing but, again, tracking algorithm. They are all video. Everything is a video. I don't know. They are not working. Maybe the version. So anyway, so mean shift and cam shift are the two tracking methods which we have used here. Some new methods of tracking we have used. So they are much modern methods. Next. And then these are it is unfortunate that it will not move, but anyway, this is the one particular, I don't know, none of the video is working. Okay, next, after that, video segmentation in object clutter. Let's go there. So, in an object clutter environment where there are a number of objects, we have used a number of methods of segmentation. They are called image segmentation. Something is available in the book. This is video segmentation. The methods are region drawing, k-means, mean shift, watershed, graph cut. All these methods are done. Why? How do you know which method is okay for this environment? Different environments are there in front of you. And please remember, if you have the quality metric parameter, what I'm going to show you for segmentation, you will know why computer science is essential here. These are the things which is pure, deep computer science work. So these are the different algorithms which has been all coded by C++ and put it in Ubuntu environment to put it very easily in the hardware code. Nothing has a value without a hardware code here because everything has to work on real time. Next one. So These are the segmented regions output. And these are the parameters. So these are the gray level energy. So a number of parameters are there. These are the parameters which are called quality metric parameter, which judges the different algorithms and find out which is the best algorithm. These are the results of this scene. I segment this scene, I get multiple different kind of output. And these are colors is nothing but a false color. We have put a false color to show, are we going to see the exact region? See here, here is a road, here is a road, here is a road, here is a road. Something, there is a cut. Some places, some methods are giving you a clear road. You know, some of the methods only will give you the correct result. And see here, all the different regions, we have put false color. This is a false color only, just to see that whether I am able to distinguish the different regions which are free for the robot to go. I have an environment where I have gone, where multiple objects are around, but I want the mobile robot to move through that. So in order to do that, I have to test different algorithms, find out the quality metric parameter, and find out which is the best algorithm. This is the only way. There is no other way. You can't just like that pick up an algorithm. Nobody will take it. Nobody will take your work. Next one. So this is very sad because this is one of my best work where all these are video. We have to show it some other time in that case. All these are video where through this object, robot will pass. Every time there will be multiple objects in front of it, but he will still be able to find the path. This is all these are video. Next one. So algorithm for processing low illumination environment. So that was here is a completely dark region. These are the different algorithms. These are all adaptive algorithms. These are the different short name of the algorithms. All these algorithms give different kind of results. You see here, for this scene, to make it lighted, have you seen 1, 2? You didn't know that it is here. You didn't know it is here. This is the where the robot is going. But you didn't know his presence in this screen. Screen looks like this. The algorithms have changed, but some of the algorithms are better in your eye, some are not. But you don't see it with your eye. You take the parameters here. These are the parameters of different enhancement. Again, quality metric parameters are different for different algorithms. These are all available in the research papers only. And with that quality metric presentation, you can find out which is your best algorithm. Here we found out the best algorithm, and that algorithm will be used for here. Brightness preserving by histogram equalization, BBH is the first one of the method BBH. Then comes all the different algorithms, dualistic sub-images histogram equalization, recursive mean square histogram equalization, adaptive modified histogram. All these are different, weighted and thresholding histogram. So there is a variation. Histogram equalization is one of the earlier work which people have done, but there are a lot of modification has come, and those things you have to use to be able to know for my scene which is my best algorithm, where I can see everything. And when you get the algorithm, you use that algorithm for your work. Next one. So it is next slide will be sad because here you cannot see. This is actually the scene. And once you apply, this is a different algorithm called Regulator algorithm. Single scale reflex, multi-scale reflex. This is a different kind of algorithm. Again, enhancement, but it actually models the human eye. Instead of this one, the human eye will be modified by the algorithm, and you will be able to see a different scene. You will not see this scene, you will see this scene. That is the goodness of this. They are all famous algorithms, and these are the algorithms which has been used. And there again, I have used quality metric parameter to be able to find out in my Regulator algorithm. This is called a ACM journal. This particular, all these papers have been published in the best journal, one of the top journals, only because of the type of work, but done by only undergraduate students without matters. Next one. So you see, these are actually video. It's really sad that a single video doesn't work. Anyway, I have to make one more attempt to show this video. I'm really sad that I can't show you the video, but we have to have some premium machine one day where this meeting must be organized, and I'm really very much particular about the students. Students must see that. I want the students to see this and then get a feel that it is not that difficult. All of you put effort can do that. There are enormous amount of algorithms out there. Then this is in cloudy environment. This particular, here I have got different algorithms again. And this is the environment. See, this is the input. And here are the outputs you see. And this particular boy is actually going to US now. He is a student of mine, done a lot of work on video processing. Yeah, his work is different. This is not his, he has done this work in addition to his BTech project because I called him to do this work. So he's been in the team. So these are the different algorithms which when you again you find out the QM parameter, quality metric parameter to find out of these four different output with 4 different algorithms, which one is the best. Next one. And this is actually, these are all the video where we definitely we have to make an arrangement by the people here who should help me to show it to the students. I am very much interested that the students see that and get excited that this kind of work can be done. And these are all youngster undergraduate students. And all of them, a major of them have been taken by Robert Bosch, some of the big companies, and some of them are Philips Software, Robert Bosch, all these companies they have gone, and they are all going to go to US, maybe just at this end of this year. Next one, please. And this is a not denoising. So here it is an environment which is full of lot of dots, sand particle, and these are the algorithms. A number of algorithms are here. All these are adaptive algorithm, alpha trim, min filter, contra-harmonic filter, adaptive DWMTM. DWMTM is a very well-known algorithm. And all these different algorithms again uses some of a new work is still there, which I have not got it yet. Next one, please. And then you show again the quality metric parameter for each of them. Without quality metric parameter, we do not move an inch. I take this quality metric in 6th semester for the students who are doing research with me, so that they understand that and make some good work out of that. Next one, please. So this is, of course, this part. From this part, this is a part of DST project. This part, which is used with a team of students. He is a research associate. So this is using the different kind of neural network. This particular RCNN, this is RCNN, a kind of network which we have taught. All the data has been taught to the network, and RCNN has been, this is the architecture of RCNN, and this solves and this find out the tracking. Next one, please. This is CNN based tracking, and this one was done again with YOLO network. YOLO was used, and they are also same thing. You see all the things which is being done by cloudy environment, noisy environment, everything works here. But there I have separate program. Please remember that. I showed you a separate work for low illumination, separate work for segmentation, for the lot of objects on the ground. I showed a separate work for cloudy environment and noisy environment. That the goodness of the convolution neural network is you do not need anything. You just need one network architecture. This is a YOLO architecture. And on that, all the different algorithms can be solved in one method. Because we have taken the data from that, input, output, and fed it to the network, either noisy or cloudy or a lot of objects. Everything can be done by one method. That's the goodness of CNN. Although I'm a little critic of that because of the block, everything has been put in a black box. Next one. So these are the final results which are shown to test. Next. These are the different. Next. So current research, I'll just show you very short. Next. What is the current work we can do in this institute? Go to the previous. What is the work we can do in this institute? In this institute to empower our students. You have known, you have to learn how to separate the object from the ground. And now what you do, you take the head part, you take the body part, you make the leg part, and you see the movement of head. The person is always looking back because he has done some not good activity. So he has a doubt on other people that other people are seeing. The person is running fast. You see only this part. You wanted to see the whole part. And then you do all this and then try to find out activity of the person. Activity tracking is one of the very important area of research across the world. See the US university, the kind of projects the student does. Activity tracking takes a major part. So we need to do some work on that. Next one. And these are the humanoid robot. This particular robot was run at the beginning, and this robot, the name of the robot is Arya, and then came Tia, who is the next generation robot. And all this robot were made in-house by using 3D printing machine. Design was done by mechanical, but 3D printing, I make sure that even the CS students knows, computer science students knows how to use the 3D printer and get something. I have got some 3D printer machine. Next one. And then comes the CAD design of ARIA, and then it comes how it was converted to here. Next one, please. So these are the different activity it does. If the video doesn't work, this will not work, but I'm just showing you this. These are the activity it can do. You tell him to do it. You have to just give a command and it will do that. Okay, next one. Then I have brought something which is very, very interesting called health monitoring system. Next one. So these are I developed this health monitoring system in DRDO when I was working on UAV program. Now this particular thing is normal. These are the response of all the parameters. Different parameters are there. These are the response of the parameters. So if something goes wrong, robot doesn't work, one curve will not come, you immediately know which one has a problem, which motor has a problem. This health monitoring system I have introduced in this college where I am working for last 11 years. And every system, be it satellite, be it robotics, be it anything, there is a health monitoring system so that quickly we find out where is the problem. Students have done the work. There will be always some small glitch. It doesn't matter. I can immediately, I'm not embarrassed. If something doesn't work, I will jump to my health monitoring system, find out which motor is not working. Next one. This is a concept. This is a concept I brought, and it has got a great name everywhere. And I would like here also, people should do the similar thing. See here, you have given different type of interaction, turn left, here you have given turn right, roll left. Everything has a different kind of response. And when something goes wrong, some particular part is not working, you will know which one is not correct. Okay, next one, please. Next. So, research in satellite technology, wanted to just show you 7 engineering colleges together with Karnataka and Andhra Pradesh made the first. This was the satellite. You see here, this is the small satellite, 850 gram. It is put in ISRO's Cartosat 1200 kg. This is the satellite, 850 gram called Student Satellite StudSat. This is the only institute which first put the student satellite on the orbit. This is the flight of the satellite. And I want to show you my best students on second. Let me see what I thought I forgot. Let's see. Next one. Next one. Next slide. Yeah, these are the components, not required. Next. Now, this is a system. This was our patent because what we could do is we developed system where now this is the current satellite antenna is on our roof of the college. Now, current satellite is passing. I can see that amplitude very good. I can see the satellite. I can track the satellite. This is the tracking area. Next one is coming after 4 hours. 4 hours. After that, these things are coming at night. I need not see them because the amplitude is so low that I cannot track the satellite. My objective is the satellite will fly on the, it is in handband, it will fly on the top roof, on the sky of the college, and that I will be able to see on that antenna. So students will be able to track that, but here not. So we can do it for one full week. One full week data we can generate. We develop the system. Next one. This was all enough. These are my best students. This is the US Rao, who is the UR Rao, who is one of the father of the ISRO program. And these are my best students. This boy is in NASA, and this girl is in UK. She is doing one of the top jobs. You will be happy to see this. You know what it is? This is the first Indian team. All these students are in different places in the world. Only thing, this girl got married with this boy, I think this boy, who is her husband now. He's one of the students who has worked with my Dr. Majumdar, my husband. Anyway, so now all these people have gone to Mars mission in Utah. They are the only Indian team who has been selected among, because International Space Station gives invitation to the students of the world to come for Mars mission to create an atmosphere of Mars in, this is Utah, in Salt Lake City, USA. So there, they have made some experimental setup. This Indian team was selected. All these people are our students in that college, and all of them have worked on the satellite. It's a matter of great pride for us that these students are doing fantastic in their field. Next one. So this is the ground station. This is the first satellite, small satellite ground station, which was SRM's is University Chennai, IIT Kanpur, and Surrey Space Center UK. All of them have used this for flying their small satellite. So this was our patent again in this project. I have got some award if people are interested. There is one more slide is there. Click that. No, one more. Yes, I don't know this. I'm not doing this. See, there is one file called award. Close it. No, 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 no. You have to come up. Close it. Open this. Not this. Printer. Printers.
Yes.
That's just. Yeah.
Upward.
No,
Yes,
the
this
next
is
middle one. Yeah. Robotics, under robotics. Under the third. Third. Yeah, third one. I wanted to share with you people some of my awards what I have got in my after I have come to DRDO. Next one. So this is the first one is the VM Katke Award, which is given from Chairman ISRO has given that, but this is actually the award given by Aeronautical Society of India. And the second one is with my first interaction with Abdul Kalam, when he heard my lecture and then he came and asked me, he was asking me where I was a professor. I said nowhere. And that time I came to DRDO and he took me to missile program. First missile Agni project I won. This is the panoramic mosaicing. When we first started doing with the UAV data, I was one of the project director. I was explaining to George Fernandez. He wanted to know how this can be generated from the day when the aircraft flies. This is the next one is our director of the Institute of Aeronautical Development Establishment. This one is the air show where I was explaining things to Pranab Mukherjee when he came, when the defense minister he came and wanted to see what are the work I have done. And I have always, till my retirement, every year in the air show, I will have a stall next to Israel. And Israel people I know very well because of that. And I was explaining to Pranab Mukherjee. So that was the thing. Next one. This is my next award, Shuman Sharma Award, which I got from Institution of Engineers, and this particular. Then receiving Prime Minister's Performance Excellence Award, I replaced the system which was being imported from a system for which the aerial vehicle when goes, how it is working, intelligent things it is doing, and sending the things, all the finding to the armed forces. This is the work I did, and I got Prime Minister's Performance Excellence. This is the director who is giving me that. He has gone to Delhi, got the award for all of us, and then he is going. I am one of the person who got the Prime Minister's award. Okay, next one. This is left side is Stanford Research International, where I was invited from DRDO, and I got an award from the President Stanford Research International. That is the left one, and immediately our Indian newspaper put it in the news. Indian newspaper placed it in the paper. Next one. This is the one big conference. ICBGIP is one of the most prestigious conference. The first day I organized with the top research center of Stanford. These are the people. Actually, this Sardarji in the right side is the top boss there. He is a Sardar, but he is there. He's a very famous person. And all these people are scientific advisor and all these people. That is the first time we had done a deal with those institutes, that institute in US with Indian DRDO. So that was the thing, I did it. And this is the first robotic exhibit, what I did in Hyderabad Museum. It was installed, and Dr. Abdul Kalam in the next picture is asking me why I am in Hyderabad, I am not in Bangalore. And I told him, if you forget about the retirement age, I will come running to DRDO. So that is Abdul Kalam actually inaugurated that particular thing. And then this is my visit. I was invited in Kuching and Sabah in Malaysia to give lecture, and I was session chair there. So bottom is the session chair and top is I'm giving lecture. Right side is I went to Japan for the University of Tokyo to see their robots. The person next to me is actually the boss. He's a youngster. He's a brilliant boy from University of one second, I forget the name. He's one of the top university of the world. He's a PhD from there, and he has been the head of Tokyo Robotics Center. Next one, please. So this is my invitation in England, Computing Conference London, where my student, who is the next person to my screen, is the next student who is today is one of the just 1.5 years back he has gone. He is today a top person in University of Southern California in robotics. And both of us have given lecture. This is one of the first conference has taken place between ISRO and DRDO in Research Center Imada, and Surrey Space Center director has come, that is the right side, and left hand side, 5 people got the award. These 6 people got the award. The 5 people are from ISRO scientists who have all done that constellation of satellite, and I am one person who has started working on satellite disaster management, and they are very much interested that I must do work on this area. So that is the picture, we got the award, that's the reason, that is the award picture, and right side is the student satellite. The first person on the left hand side is actually the student satellite project director, and these 2 are the Surrey Space Center director, and I know him very well, and this is his assistant. Next one, please. So this is my visit in China, where I was an invited speaker. This is from one Indian professor is there. He's not here. Okay. This was the person who is from US, and then here is the discussion meeting going on. This is the professor from Indian Statistical Institute, Calcutta. He is an extremely brilliant person in quantum computing, and he is being invited everywhere. So this is I'm giving lecture. Next one. Next one is my visit to Japan, where I went as an invited speaker, and this is the person from University of he's a very famous person from the world. I forget his university. Anyway, Berkeley, University of California, Berkeley, and we are having a discussion about the neural network, how it has come to different engineering streams. And this I am giving lecture. Next one, please. And then I went to the Diabetic Congress in the 2019 as invited speaker for my work of data analytics in medical. And here is this person is actually the head, this Italian professor, and I became the co-chair of all the session. And here I distributed the certificate to the different participants. Next one. And this is the Sesame Award, which this is one of the top project award where government of Karnataka, this is the minister who gave me the award. This is the principal of the college, and I received this award. Two such award is given every alternate year, and I got a particular year this award, and this award is 20 lakhs every year. You give to the college who does that for their research. Next one. This is my very recent. There I give the humanoid robot which teaches a child with autism. So I was demonstrating it to the education minister of Karnataka, and there was a big gathering there where this is whole my team. All people are my team people. I took all of them to show that no single person can work on that. We did enormous work on that. Okay, I think that is the one. Thank you very much.
So, can we expect some questions? If there is any question, all of you can ask. So if there is no questions again, then can some students may.
Students do not have any question.
Say them to me.